If you're a HC Chemistry student studying Module 6 this term, this video is for you. I genuinely mean it when I say it, but Module 6 is probably the hardest module of the 4 modules in Year 12. So the last thing you want to do is to go into this term with no plan, no strategy, and no idea of what's about to happen in this module. In this video, we'll cover what's in Module 6, and we'll actually rank all the topics in a tier list so that you know what's important and what's not. We'll also give you a roadmap or a timeline to tell you exactly when to be studying what, and hopefully this will give you some guidance as to where you should be in your study throughout the term. And I could go on for another hour about how to study chemistry, but I've already made that hour-long video right here. Click on that and you'll be taken to that video to learn how to study chemistry more effectively. Before we get into today, I'll just introduce myself quickly. My name's Jeff and I'm the head of chemistry at Catalyst Chemistry. I've tutored chemistry for about 5 years now and I know a thing or two about the subject. I graduated in 2020 with an ATAR of 99.7 and I got a 98 out of 100 in chemistry. This mark was pretty much the only reason why I was able to get into UNSW medicine, which is my dream degree. My goal from these videos is just to pass on what I know about the subject to you guys so that hopefully you can get into your dream degrees as well. So enough from me, let's get into the actual video. All right, so starting off with what's in Module 6. Best place to find this information is, of course, the syllabus. So this is what it looks like. You can find this online. Just search HC Chemistry syllabus. There's not too much information in the outcomes. We can summarize the content focus as basically you need to know what an acid or base is and how that changed over time. You need to recognize how they exist in the real world and how you can analyze them qualitatively and quantitatively. But I want to focus more on the content and the inquiry questions of Module 6 because this is where you actually get the meat out of the syllabus. There are 3 inquiry questions in Module 6. The first inquiry question is properties of acids and bases. This is a very foundational inquiry question where you learn a lot of broad concepts that are a bit detached from each other before building on it in the second inquiry question. The second inquiry question is using Bronsted-Lowry theory, a continuation on from the end of Module 1 where you introduce all the acid theories. You now have to apply one of the more recent ones in Bronsted-Lowry's. And the final inquiry question, and probably the hardest of the 3, is then quantitative analysis. If you do not like math, you are not going to like this inquiry question. So this one's the one you're going to have to put the most time and energy into to get good at Module 6. Okay, so the way we'll grade these is based off 2 factors. Number 1, how high yield is the topic? Is it likely to come up in your exam or not? So more likely is going to rank higher, less likely lower. The second factor is how well do people across the state know this topic? And based on my experience, I can tell you what people know well and what people typically struggle with a bit more. So studying that topic is more likely going to differentiate you from your cohort. And then before I rank each one, I'll just talk quickly on what the actual concepts are and what you'll need to know roughly. So our UPAC nomenclature, you just need to know how to name an acid or a base. For the most part, the acids you'll see in HC chemistry recur over and over. So there's not really anything too crazy or too new that comes up most often. And if there is something crazy, the question stem in your exam has to specify the name and the formula of that acid or base anyway. I would say the yield is therefore like moderate to low. And is it going to differentiate you from the state? No. So I would say this is a D tier. You're not going to get much yield out of studying this. Okay, secondly, indicators. Indicators are pretty useful. You're going to be using them through titration. And to outline what an indicator is very quickly, it is a substance that changes color in different pH environments. I tell all my students you need to take into your exam 4 indicators: litmus, bromethymol blue, phenolphthalein, and methyl orange. And for those indicators, you need to know their colors, you need to know their pH ranges or their transition ranges, and of course, you need to know their names. So for indicators, I'd say this is moderate yield once again. Is it going to differentiate you? Maybe slightly, just because a few students won't know the indicators by heart. I'm just going to say this is a C tier. To understand what an indicator is, not going to differentiate you. Third topic is then the indicator prac, and most schools will do the anthocyanin prac, which is basically you boil a cabbage, you extract the indicator out of the cabbage, which turns solution purple, and you can test different solutions with different pHs and see different colors. Yield, I would say, is moderate to low, just because you pretty much have to be asked on this exact dot point, this exact part of the dot point to get assessed on this. But is it going to differentiate you? I would say actually yes. A lot of students neglect going over their pracs this early in the year and spending that bit of time actually understanding what's happening with anthocyanin as a diprotic indicator would probably differentiate you from your cohort. So I'm going to place this in the B tier. And then we get onto one of the best topics, indicator equilibria. So this dot point states you have to understand how an indicator is a reversible reaction, and so many students neglect to actually understand this. Is this high yield? I would say moderate to high, because teachers are getting more clever with the questions they ask. They're not asking the same boring questions. They will examine you and mix module 5 and 6 with this dot point. Given the trend of the HSC, I think this is a pretty high yield dot point. And on top of this, it's going to differentiate you because this earlier in the year, once again, people aren't going to be able to discuss 2 modules at once. So for that reason, I think indicator equilibria is a high A, maybe S. I'm gonna put an A tier for now. We might change our minds later, but A tier, indicator equilibria. All right, acid reactions. You've basically just got 3 reactions. Acid with a base is neutralization, acid with carbonate, and acid with metal. You need to know the products, be able to write equations for any given word equation. I would say it's moderate yield because you just have to know it. Is it going to differentiate you? No, because everyone's going to know it. So I'm going to place this as C tier. I think we missed one from earlier. So properties of acid and bases. Again, relatively low yield. This is probably just going to come up in a multiple choice question every now and then, where you just get given a few properties of an acid or a few properties of a base. You get asked which is an acid property and which is a base property. I'd say yield is low. Is it going to differentiate you? No. So I'm placing it straight in the D tier. Okay, everyday and industrial applications of neutralization. This one is definitely not a high yield topic. The way I teach it is I say you need to have at least one everyday application and one industrial application you take into your exam for neutralization, whether that is using an antacid to neutralize your stomach acid, or if it's treating semiconductor industry wastewater with a relevant base. It's really not that high yield, but what I could see this dot point being assessed as in your exams this year is your teacher actually gives you a new, fresh application of neutralization, and you have to explain how it's being used. So I'd say overall, pretty unlikely it comes up your exam, but because your teachers can ask you to talk about some weird neutralization you haven't seen before, there may be some differentiation there. So I'm going to place this as a high C tier, probably not B. Enthalpy of neutralization calculations. Oh boy. How badly are these done across our homework in Catalyst? So this is probably one of the most common question types you're going to see in Mod 6. You're almost guaranteed to see it if you have an exam this term. High yield. And when you see it in a different context for enthalpy of combustion later, it's important you differentiate this as a completely different topic. You're using 2 equations from year 12, Q equals mc delta T and delta H equals negative Q on N, to calculate how much heat is released from a neutralization reaction, which is typically exothermic. Very high yield, A tier definitely. And is it going to differentiate you at this time of year? Definitely, because people don't know their calculations yet. So I would say this is definitely A tier, potentially creeping S tier. I'm going to put it A tier below indicator equilibrium for now. High yield, super important, know this well. And finally, definitions and models of acids and bases. I would say this is important, definitely. High yield, it's going to come up in your exam, probably. Is it going to differentiate you though? Not really, just because of how rote learning it is. So I would say it's a crucial dot point, but is it going to help you climb the ranks if you spend your time studying here? I'd say probably not. So I'm going to place this in the low B tier for that reason. Okay, so inquiry question 1 done. Highest yield topics, indicator equilibria and enthalpy of neutralization calculations. I would focus your energy here and everything else as ranked there. Cool. So second inquiry question is using Bronsted-Lowry theory. So the inquiry question reads, what is the role of water in solutions of acids and bases? So we'll figure out what this ionizing role is at a later point in the module, but let's pick out the topics and rank them again. Firstly, you have to conduct a practical investigation to measure pH. You then have to calculate pH, pOH, and invert those calculations to find hydrogen ion concentration and hydroxide ion concentration. You then have to conduct an investigation to use pH in differentiating between the strengths of acids and bases. The fourth dot point is a few things in there. So you have to write ionic equations to show dissociation of acids and bases in water. You have to represent conjugate acid-base pairs. That's a separate topic. And lastly, you have to represent amphiprotic salts, and they've given 2 examples of amphiprotic substances you have to prove are amphiprotic. The 5th dot point asks you to construct models or animations to show the difference between strong, weak, concentrated, and dilute acids and bases. That'd just be one topic. And the final dot point is to calculate the pH of the resultant solution when solutions of acids and bases are diluted or mixed. And we'll call this one neutralization pH calculations. If you're enjoying the video so far and you're finding it helpful, leave a like down below and comment anything that you're not sure about in the comments. We can help answer them there. And if you're looking for more HC chemistry content, make sure you're subscribed down below. That way you'll get notified when we post new content and you can get all the content you need to get to that band 6 or wherever you're trying to go. So please subscribe. All right, so inquiry question 2 topics. Measuring pH investigation. You're basically just learning how to use a pH probe to measure given pHs in a prac. Not exceedingly high yield. I would say some students may get caught on this just because they haven't revised it properly. I'm going to call it a low C tier. Not that interesting. Calculating pH, POH, H plus concentration, OH minus concentration. Very, very high yield topic. I'm going to put this in probably A tier. I'm thinking, is it going to differentiate you? No. But is it essential to all of the calculations you do that involve a hydrogen ion concentration or hydroxide ion concentration? Pretty much. So it's going to be, probably high B tier. I think it's probably just a little bit less important than the definitions of acids and bases. I'm going to put it right here. Using pH differentiates strength. This prac is strangely misunderstood by a few students. So the tricky thing is that pH is affected by 3 factors, and you should know it's affected by strength, concentration, and the proticity of an acid. So basically, when you do this prac, to figure out strength, you have to fix the other 2 in place. If you can explain that and walk through that prac, you're okay. I'm going to call this a low B tier. It's still going to catch some people out. Not very high yield, but again, because it's a prac, I think you have to give it respect. Knowing the difference between strong and weak and concentrated and dilute, and be able to draw diagrams to represent this. Very common question. Is it going to differentiate you? Probably not. So I'm going to call this a high C tier. Common question, but pretty stock standard question that everyone really should get. Similar idea with acid-base dissociation equations. You see them from pretty much the start of the module all the way up to this point. It's not that much of a surprise. Are you going to use them a lot? Yes. Is it going to differentiate you? Not really. So again, probably in the C tier. I'm going to place it just about here. Conjugate acid-base pairs and their strengths. Now, this is an interesting one because it's a common question where you get asked to find the conjugate acid and base pairs for an equation or a neutralization of some sort, and you're asked to find the acidity, basicity, or neutrality of the salt that you form. And a lot of students, if you haven't seen this type of question before, you have no idea where to go. I remember myself, I got caught out in, I think, my term 1 exam by this question. I just had no idea. So I will say this is a B tier. It's probably a strong B tier in my opinion, just because of how easily you can get caught out if you haven't seen it before. So I'm going to place it here. Okay, amphiprotic substances. You should know an amphiprotic substance is a substance that can either donate or accept protons given the chemical environment. You should be able to write equations to prove any given substance is an amphiprotic substance. And this is basically just where you react the substance with either hydronium or hydroxide in those 2 equations. And that's enough to show it's amphiprotic. So for this topic, I'd say it comes up relatively often in term 1 papers, definitely. Is it going to differentiate you? Probably not. So I'm going to place it as a low B tier. So finally, neutralization pH calculations, and following theme from today, I think you're going to very quickly pick up what is really difficult and important from Mod 6. And neutralization pH calculations, like enthalpy of neutralization calculations, you just have to know how to do it. It's a question that is almost certainly going to be in your exam in term 1 and will be in your exams through the year if you keep having Mod 6 in them. I would say this is going to be A tier for sure. I would say this is even more common than enthalpy of neutralization and probably even more common than indicator equilibria. I think this is probably our best bet at an S tier thing to revise for Mod 6, just because of how common, high yield, and differentiating it can be if you get a difficult one of these questions. So our first S tier entry is neutralization pH calculations. The final inquiry question for Mod 6 is of course quantitative analysis, and this is where things do get a little bit more challenging. The inquiry question reads, how are solutions of acids and bases analyzed? And of course now we have to do a little bit more calculation work in this final inquiry question. First dot point, conduct a practical investigation to find the concentration of an unknown acid or base by titration. Second dot point, you have to investigate titration curves as well as conductivity graphs. Now these are two separate things, two separate topics. And within these two topics, you have three types of titrations you have to know the curves or graphs for. You have to be able to model neutralization of strong and weak acids using a variety of media. You then have to calculate and apply the dissociation constant Ka as well as pKa. And this is inverted as well for base. You have Kb and pKb to find the differences in strength between strong and weak acid and base. You have to explore acid-base analysis techniques that are applied in industries, by Aboriginal and Torres Strait Islander peoples, and by using digital probes and instruments. You have to conduct a chemical analysis for a common household substance for its acidity or basicity. You have to do a practical investigation to prepare a buffer and demonstrate its properties. And finally, you have to describe the importance of buffers in natural systems. So let's have a look at what all these topics will rank as. So there's a ton of topics in the final inquiry question, starting right off with titration. Titration is basically a method where you are combining two solutions, one which has a known concentration, one which is unknown, and you're determining the concentration of the solution that is unknown. There's three main ways you do titration in HC chemistry, but most importantly, you need to know titration procedure. Knowing the titration procedure well and knowing the fine details will differentiate you despite everyone knowing roughly what happens in a titration. So paying particular attention here puts titration procedure definitely within the A tier, and I'd probably place it just above enthalpy of neutralization calculations, and actually probably above indicator equilibria as well. It's in the A tier, that's for sure. Maybe pushing S tier. Things to watch out for in particular with titration procedure. You want to watch out for rinsing procedure. You want to watch out for when you take a rough titer or not. Those kinds of things are what people make mistakes on. You need to be confident discussing exactly what you should be doing at every point in the procedure. So then the three titration types. Titrating using an indicator, A tier, easy. And for these, I'm attaching the calculation under it as well. So titration using indicators and the calculations associated, easily A tier. I'd probably say even above titration procedure. I'm going to put this in the S tier. Super common, probably makes up 70% of your titration calculation questions. So I'm going to put it above neutralization pH as well. Back titration, a bit less common, but I'd say more common than it was a few years ago. It will differentiate you. It will probably come up at some point in an exam that you have. And because of how differentiating a back titration question can be, I'm going to place it S tier just behind your standard titration using indicator. Finally, conductometric titration actually isn't that complicated, so it's not as difficult. Doesn't come up so much, but just because you should be able to discuss a conductometric titration as well as do the calculations, I'm going to place it in the low A tier just here. And just to ram home the point, for any titration calculation, if you're revising titration calculations, you are probably going to be doing better in your Mod 6 exams. I'm just going to place this generally for all titration calculations in the S tier. And it's so important, I'm going to place it twice. Okay, as if there wasn't enough titration content, titration curves. So this is your pH curves that resemble a sort of S shape usually. You have to be able to discuss what is happening at each point in the curve and justify it using chemistry terms. So actual equations, talk about equilibrium shifting if it's in the buffer zone, talk about this equivalence point and what's actually happening for the pH as you add base or you add acid into your analyte. I would say titration curves are also S tier. So common, so high yield, and being able to really step through this systematically will differentiate you. Conductivity graphs. I'd say honestly equally as important as titration curves and probably a little bit more differentiating because people spend a lot of time on the titration curves and not as much explaining the more pointed conductivity graphs. Same idea, you have to be able to discuss what's happening at every single point, talk in terms of chemistry, what's happening to concentrations, and I'm going to put this just above titration curves just because people will miss it when they revise. Back down to earth, modeling strong and weak acids and the neutralization reactions they perform. Basically, you can just talk about a molly-mod kit here and how you perform that. I don't think this is overwhelmingly high yield, probably a C tier, to be honest. Ka, Kb, pKa, pKb. Yeah, enough said. It's going to be big. These are the questions that differentiate pretty much rank 1 from rank 2, 3, 4. It's the top of the cohort that will get these questions right and negotiate Ka, Kb, pK, pKb very confidently. Because of the differentiating factor, I'm going to put them just above titration calculations. You should be confident converting between these terms. You should be confident saying what they actually mean in words. For example, when you have a big Ka versus a small Ka, or a big pKa versus a positive pKa versus a negative pKb, you should be able to tell me what that actually means. Acid-base analysis techniques, not overwhelmingly important once again. Syllabus is shifting away from rote learning. I'm going to place this in C tier as well. Analysis of household substances, at least there's a prac attached here. I'd say this is probably a little bit more difficult than measuring pH investigations. I'm just going to place it here. It's not on my radar of important topics. Preparing a buffer prac can go unnoticed. Again, a differentiating one, but not super common. So I'll place it as a high C tier. But buffers themselves, I cannot explain how many times I get asked to explain what a buffer is every year. It is so poorly understood. It is the easiest way that you can differentiate yourself. So I'm telling you that if you understand buffers and you understand them well, and your cohort gets slapped with a buffer question, whether it's a buffer explanation, explaining what a buffer is and giving some examples of buffers, or if it's a buffer calculation, you will be performing better than your cohort. I almost certainly guarantee it. So buffers, spend the time. It is definitely worth the while. And being good at buffers, I would rate these as probably, I would say this is just underneath your titration calculations. And I just realized Ka, Kb should be up here. Buffers in natural systems is just giving your example of a buffer in a natural system, typically more of a rote learn style question. But in more recent times, question writers will give you a buffer in a question stem. They give you the equation. They ask you to explain how these two equations can act as a buffer when you add acid or base to them. So I think whilst the rote learn component is probably like a C tier, low B tier, the applied aspect of this question, and again, the fact that no one understands buffers well, I would place this probably in the A tier, in amongst indicator equilibria, probably just a bit below actually, about here. Okay, so that rounds out our tier list. We have all of our S tier topics. Titration is all in there, Ka, Kb, pK, pKb, buffers, neutralization pH calculations, conductivity graphs, titration curves. I like that list. I think that's where you need to direct your attention mostly. Everything else is secondary. Obviously focus on A and B as well, but everything in the C and D tier, probably turn your head away. Once you've covered it, you've kind of got it. But if anything is in the S tier and you don't know what's going on, spend the time. I guarantee it'll be worth it. But wait, there's more. So there's actually two topics I would say that aren't clearly outlined in the syllabus, but still do get assessed very, very frequently. And they come from the relationship of pH and pOH. So we should recognize that pH plus pOH equals 14. You learn this once you basically learn pH, pOH. It's kind of tied in with that dot point, but not very clearly. This relationship is not overwhelmingly high yield, but it isn't on the data sheet. So there is a bit of differentiation here. I'd place this about high B tier. But what is very underappreciated is the concept of Kw and what it actually represents. You learned that water auto-ionizes with itself because it's amphiprotic to make hydronium and hydroxide. But the equation from that is very underappreciated and definitely comes up in exams. So I would put a bit of time to look into Kw just because people don't get it. So, and again, one of those topics that you can so easily differentiate yourself on. And I'll place this in the, I'll place it in the high, no, it's a low S tier just because of the differentiation. So this is now the complete list. If you stuck around to the end, you got the bonuses. These are the topics that don't even appear in the syllabus properly. Now you know to make sure you have those covered. So now that we've actually talked about what's in Module 6, the last task for today is we have to talk about how you structure your term to crush your exam in the most systematic way. The number one thing to understand is that no one is inherently better at Module 6 than the next person. You may have a slight edge if you're mathematically better, But the people who perform better in Module 6 are those who've just had more practice and a longer period of time to practice. And that's why at Catalyst Chemistry, we take our students about 3 weeks ahead of class pace. Because when you walk in the classroom and you already know what's going on for the next 2 weeks already, it just becomes like a revision session. And you may have experienced the person in the back of the class just raising their hand and knowing the answer to every single question. It's probably just because they've seen the content before and they've done it before you have. So I know it may already be too late this term to get a head start, but if it was up to me, I would suggest you get a 2 to 3 week head start on Module 6. That way, you're just that bit more comfortable when the exam comes around at the end of the term. And if I was to be plotting this on a number line, I would be starting Mod 6 right at the start of the holiday, to be honest. You can make use of a tutoring service like Catalyst Chemistry, start at the start of the holiday. That makes your life a lot easier. You don't have to, you can do it on your own if you want, but it will save you time. And in this year of the HSC, it's all about time. I'm telling you now. So if you start Mod 6 at the start of the holiday, what that will allow you to do is when you start Term 1, Week 1, you're already at pretty much the end of Inquiry Question 2. The first 2 to 3 weeks then you're spending learning Inquiry Question 3 on your own, whilst at school they're just toppling Inquiry Question 1. So I'll put school pace in blue. If you do all the questions we tell you to do at Catalyst, you would have done already 150 marks worth of questions by Week 3, which then allows you to independently practice on your own from Week 4. We have our question-based session then. Week 5 is our mock exam. Week 6, you review your mock exam. And then Week 7, we just review everything before your exam is actually happening at school. And if you were to do this school pace and you just follow the pace of your class, in Week 3, you'd be lucky to get onto Inquiry Question 2. If you move excruciatingly quickly, you're going to get onto Inquiry Question 3 by Week 5. And if you cast your mind back to how many topics were in Inquiry Question 3, this is going to bleed into your exam period. And that is not what you want. Inquiry Question 3 takes time to learn. It's quantitative. You need repetitions. So if you are in this boat where you go through the school's pace and you learn Inquiry Question 3 whilst you're preparing for your exams, it's going to be a disaster. It's not too late. Even if you are a little bit further down the line in the term, just become aware that as the term pushes on, you need to realize that if your school isn't moving through Inquiry Question 2 and 3, at least at this pace, you need to do the work yourself. And that is not an easy task. But hopefully you prepare for your exams well and they all go well. If your Mod 6 exams don't go so well, or whatever module you're taking this term doesn't go so well, Catalyst is here to help you out. Our course starts 3 weeks before the next term starts. So term 2 would start, count 3 weeks back, and that's when Catalyst courses start. We'd be doing Mod 7 in Term 2. We also offer Mod 6 again if you're doing an alternate stream. And in Term 3, we pretty much do entirely Mod 8 because most schools will finish on that smaller module. So if that sounds interesting to you and you think you might benefit from it, check out the link in our description to our website. Have a look around at what we do, our results, and you can submit a form to express your interest. We'll reach out when we have classes open and we'd love to help you achieve your dream chemistry marks. So with the roadmap planned out, the most essential thing that you need to succeed in Mod 6 is an early start, lots of repetitions of questions, which then allow you to attempt the harder questions and actually potentially score marks. As a general rule of thumb for any examination you sit in HSC, you need to have done at least 3 past papers of a similar kind to what your assessment is going to be like before you actually go in and take your assessment. So for Mod 6, I'd be taking 3 Mod 6 style mock exams before you sit your actual school's Mod 6 exam. Or if you have a practical assessment, ask your school whether they have any past prac exams that you can try beforehand. That would be probably the most helpful thing for you. As an added reminder, you should have your assessment of notification as soon as possible in the term. Obviously go through it by yourself, but it'll be a great idea to send it to your tutor if you have one. That way they can tell you what's actually important and what's not, and where you should spend your time for that particular assessment. Case in point would be if you have a depth study, there's no point preparing for an exam. So prepare for the depth study and just do that. As I said at the very beginning of the video, I'm not going to go through how to study chemistry. I've already made a massive video on that. So it's going to be up on the screen again somewhere here. Feel free to click on it wherever it is. And if you click through to that video, it will help you to understand how to think about studying chemistry, what methods you can use, and my advice that helped me to personally succeed in my own HSC chemistry year. So you've made it to the end. That's pretty much all I have to say about Module 6. There's not much more I want to say about Module 6 by this point, but the main takeaways from today is that Module 6 is about acids and bases. There's 3 inquiry questions. And I would say the most important of the 3 to spend your time studying is the 3rd quantitative analysis inquiry question. We made a massive tier list of all the topics, and you now know what the high yield, really differentiating topics are, as well as those you probably shouldn't spend as much time on. We also roadmapped out the way to succeed in HC chemistry. Big takeaway is to start earlier, get repetitions in, do lots and lots and lots of questions. And that's just the way you win in Mod 6. It's really that simple. Make sure you click the like button below if you found this video helpful, and be sure to subscribe if you're taking the HC this year or next year. That way you'll actually get this content in your feed and be able to do better in your HC chemistry exams throughout the entirety of this year. See you in the next one.